Hello, folks. Hope you're doing well. So, this is Pradyut Banerjee, your host for this particular channel. The channel name is your Bio-ProTech. In this particular channel, we are trying to come up with tools and the demonstration of the tools regarding your bioinformatics and AI-based solution for your bioinformatics, biology, and your life science-based studies. Okay, so I have shot many videos on that particular thing, so you can check out the channel for that. So if you like what we are doing, so you can consider liking the videos, sharing the videos with your peer ones, and also subscribe to the channel. Okay, so in today's demonstration video, we'll be looking at PyMol. So that is basically a visualization tool. Okay, so I will go in depth on your PyMol. So I will start from the absolute basics of how to install PyMol. Then we will look at what are the things PyMol is capable of, how you can utilize the PyMol for visualization of your protein structure, ligand structure, then interaction of those structure. Apart from that, if you want to pursue docking and want to study the results of that, you want to see the interaction between the ligand and the protein. In that particular case also, you can also use visualization tools like PyMol. It is not that only PyMol is there. Okay, so there are many tools like your Rasmol is there, Chimera, then your then you have your Discovery Studio. Okay, Protein Plus, many tools are there. Okay, then Swiss Doc also provides a tool for WebGL is a tool for your visualization. But yeah, PyMol is from Schrodinger, and we can visualize a whole lot of things over here. Okay, so we will start with absolute basics of how to see the basic structures of your protein ligand. Then we will see the interactions of it. Okay, how you can identify the what do you say, hydrogen bond, this, that, at atomic level, how you can understand the interaction between the molecules. Obviously, for that you need to do docking first in order to know the interactions. And if you want to know about how to do docking using AI based tool and bioinformatics based tool, the video is already there in the channel. You can go and check it out. Okay, so yeah, so basically, we'll be talking about the details of PyMol in today's video. Okay, so this is a what do you say, one-stop guide for your PyMol tutorial. Okay, so you don't have to go to any other channel to learn PyMol for say. Okay, so that is our aim. Okay, so when we start, we try to cover it from your installation till whatever the things you can do with it. Apart from that, you can also use PyMol for your publication ready images. Okay, so let's suppose you are doing an in silico based study. For that, you want to showcase a particular protein, okay, in a particular cavity, or like what are the interacting molecules over there. So what are the settings that you need to have? Okay, so background has to be white and publication ready. What has to be the resolution, this, that, we'll talk about everything in today's video. Okay, so without further ado, let's get started. Okay, so first things first, so let's discuss about how to install PyMol first. Okay, so in your regular search engine, you can just type in PyMol, PYMOL. Okay, so PyMol, so we will head on to this. So this is PyMol, the first search option that you're getting. Okay, so pymol.org. Okay, so this is from Schrodinger, and Schrodinger is a pioneer company in this particular drug discovery sector. So for your visualization tool, so and you have your Glide, so for your docking, which is a paid software. Then you also have Desmond for your molecular dynamics simulation. A whole lot of tools they make. Okay, so let's talk about PyMol more in this particular video. So you can go to download now. Okay, so you can go to download now, and you can see the options over here. Okay, so like based on what particular system you are using. Okay, so based on that, you will be installing. So let's suppose you are using a Windows, so you'll be hitting on this. Okay, so where you will be getting an executable file, exe file. If you are using a Windows and you want a zip file, so you can download via this. Okay, apart from that, if you're using a Mac OS, DMG file basically, and for Linux you have tar file is there. Okay, so archive file, so you can download from here. Okay, and so you can buy the user license as well, but it is not required. You can use it for free. Okay, for a number of days, so it will give you a warning, but don't worry about that. You can use it like anyways. Okay, so you can use it for free, so that is there. Okay, so you just have to hit on install. So I am using a Mac, so I will hit on this. Okay, and I will have the DMG file alongside. Okay, so like I will have the DMG file by my side. Okay, so once I have that, okay, then I will hit on install. Okay, And once I install that, it will look something like this. Okay, so let me show you. Okay, so once I install that, it will look something like this. So yeah, so here you can see this one. Okay, so this is PyMol. So if I double click on this, so it will be opening for me. Okay, so I have double clicked on that. Okay, so here you can see skip activation. Okay, so let's suppose skip activation, and I will just do it a full screen. So this is the basic interface of your PyMol that you see over here. Okay, so once you install, either you install it in your Windows or Mac. Okay, so it will work the same. So basically you just have to accept all of the agreements that are there. Okay, so just accept and continue, and then after that you will be redirected to this particular interface. So here you can see, here you have all the knowledge. So you can see my cursor over here. So this particular, all of the codes that, or whatever you are going to do in this particular black area. Okay, so this is your like a 3D space basically. So it is having XYZ coordinates where you can basically maneuver your protein ligand, whatever molecule you are working with. Okay, then whatever you will be doing, so everything will be executed in the form of codes in the background, so that will be shown over here. Okay, apart from that, here you have very basic settings like zoom in, orient, then your undo, okay, redo, those things. Okay, but the main things are over here. Okay, so whatever actions you want to perform, okay, so this is actions. Okay, so then you have your show button. Okay, then you have your hide if you want to hide something. Then you have your labels over here. Okay, and then you have your colors. Okay, if you want to color by element or color by chains. Okay, so whatever you want to do, so likewise you can use it from here. Okay, so here you see all of the options are over here. Because I am using a Mac, so it is coming on top for me. Okay, but if you are using a Windows, so you will experience the what do you say, the options somewhere in the left bottom. Okay, so it would be in the left bottom or anywhere in the bottom likewise. Okay, so according to like according to the, what do you say, system configuration or different type of operating system, you might have the options here and there, but the options will remain the same. Okay, it is not that some different kind of options that you're getting. Okay, so it is not like that. Okay, so whatever options I am showing over here, you will be getting the same options in your system as well. Okay, so let's talk about what we are going to see today. So first of all, we will see the structure of basic protein. Okay, you can pull the structure of the protein from your protein data bank, that is your PDB. Okay, UniProt also you can pull it from. Apart from that, you also have AlphaFold based structures. Okay, so you can also take it from AlphaFold. Okay, when we talk about your ligand structure, so it can be taken from your PubChem. Zinc is there, Drug Bank is there, then your Impact is there, then Coconut is there, Dr. Deuce is there. There's a whole lot of databases. Your Bitviz is there, Hugging Face is there. So a whole lot of databases are there. Okay, so just for your sake of understanding, I will put it from anywhere. So mostly PubChem is the most widely used. I will take the structure from PubChem and show it to you. Okay, so let's go on there. Okay, so I'm basically using Safari for this particular purpose. Here you can see I will just go to Google. Okay, so just go to Google. So let me stretch it for you. I will simply what do you say, search for your PDB over here, protein data bank. So that is the what do you say, primary database which is concerning to your protein search. Okay, protein structural search. Okay, so if you want to know about more about this, I have what do you say, described this particular tool in our docking video as well, and we'll soon coming up with your detailed video on your PDB as well, how to read the file, this that. Okay, so stay tuned for that. Okay, so yeah, so let's talk about, let's suppose I'm talking about 3CL Pro. Okay, so that is a, so any protein you can take basically. So I'm just telling you for your example sake. Okay, 3CL Pro is the main protease of your SARS-CoV-2. Okay, so here you can see, so let's suppose I'm taking this particular first one. Okay, so how to select, basically based on what kind of methods it is procured using. Here you can see X-ray diffraction it is using, and resolution is also very good. Anything which is below 2 angstrom or lower the mathematical number in resolution, better resolution it is. Okay, so you can take it from there. Okay, you can go to structure and see over here, but that is not we are trying to do, what we are trying to do over here, because this will show you the structure from WebGL. Okay, so WebGL is a web-based visualization tool, so that mostly all of the what do you say, online platforms use this. Okay, be it your PDB, then your UniProt. Likewise, even the likes of your AlphaFold and all, everyone uses this particular thing. Okay, WebGL, it is obviously written over here. Okay, mol WebGL, you can see. JSMol also you can use. JavaScript it uses. Okay, so the second one. Okay, so that is there. So this is the protein basically. Okay, so you can clean the protein. What is cleaning of a protein? Okay, so basically if you want to get rid of all of the things which are not your main protein, because here you can see, if I go here, okay, here you can see it has a whole lot of things. Okay, so small molecules also it has. Okay, water molecules obviously it would be having. Okay, so then metallic ions it might have. Okay, so those things are not of use to us. Why? Because while we are, let's suppose, going for docking, or we want to visualize the protein by itself, okay, so then this particular things are not of our interest. Okay, so here we can delete it simply, like I can just delete the what do you say, we should not basically delete the polymer, although, okay, so that was by mistake. Okay, so I can go to summary, and if I can also do undo. Okay, so that is not a problem. Okay, so if I just come to structure, so you can see again it is loaded. Okay, so you can work it from here as well. Okay, so apart from that, if I want to remove the ligand, here you can see the ligand, it will also show the interaction, but this is a pre-attached ligand. Okay, so that is already being studied, and you want to come up with your own ligand, and you want to see the docking results and all. Okay, so we have performed docking using AI based tools. SwissDoc does that. Okay, diffdoc. So that particular demonstration is already in the channel, you can check it out. Okay, so it is a very detailed what do you say, docking based study. You can follow that. After docking, you can visualize your result in the PyMol. So that what we are looking at today. Okay, so this is the ligand. Okay, so you can like reset zoom. Okay, so likewise here you can see. So I just wanted to remove the, let's suppose, ligand. Okay, so target focus, it is already in focus, so I can remove it. Basically I want to remove the ligand and water molecule. So you can see here we have the clean protein, but this is just a, what do you say, web based representation, so I cannot save it to pdb and likewise. Okay, so that is why basically I have to do the same thing, but I can do it in PyMol. Okay, so PyMol, Rasmol, Chimera, this, that, or any of the visualization tool can be used for the same. Okay, so what I have to do, just I have to go to download. Okay, and I have to download the PDB file. Okay, so normally you download a legendary PDB file that you see. Okay, legacy PDB file. Okay, so legacy PDB file, so more PDB format, because that particular file is right now unavailable due to some certain reasons maybe. Okay, so nevertheless, not a big deal. So in bioinformatics, we always have to like be a problem solver. Okay, so if this particular format is not working for today, not a big deal. We can download this and save it as PDB later on. Okay, after we process it in PyMol. Okay, so this is downloaded in CIF. It can also be downloaded in your legacy PDB if it is working back then, because it is obviously an online server. Right now it is not working. Doesn't mean that whenever you are using it, it will not work. It will, by then they might fix this. Okay, that is not a problem. Okay, so I have just downloaded it in CIF format. Okay, so I can like double click on that particular what do you thing, and then I will be redirected to this particular, what do you say, your PyMol that we have just used. Okay, so let's head on to the PyMol. Okay, so I will try to, I can do three things. Okay, I can load the protein in 2 3 ways. First is your this particular accession ID you can remember, and I can use the accession ID directly to download. That is a better idea. Okay, so instead of going via this particular method of downloading, this is one way. Okay, this is one way. Wherever the file is downloaded, you double click on that, it will be opening in PyMol. As simple as that. Okay, so you can see also, if I just have to show you. Okay, if I click double times on this, okay, you can see the protein is loaded. Okay, so here is the protein that we want. Okay, but if I just cross it, okay, if I just want to cross it, and like I'm just trying to show you the another way. Okay, so skip activation and all. Okay, so I will just try to maximize it for your understanding. Okay, so let's see. So yeah, so what is the other way? Here you can see all of the options over here. So you can simply go to your files. Okay, get pdb. Okay, files, get pdb, and you can simply type in the this particular id. Okay, so this is called as your accession ID. This is basically unique to this particular protein only. Okay, so once you type in this particular ID, only this protein will be downloaded. That is your 9HFX. Okay, so let's go on to your PyMol and like go to PDB file. Okay, get PDB. Okay, and then 9xf, what was it, 9x 9HFX, pardon, 9HFX. Okay, so you can see, click on PDB structure, so hit on download. Okay, it will download the exact same structure. You can see these are the two basic ways to download or basically your protein. Okay, so that is there. So here you can see, so this is the whole protein. So you can maneuver it however you want. Okay, now see how we can clean it. Okay, so the cleaning portion is the main thing that you want to do. Okay, so you can see that I want to get rid of this particular ligand that is there. Okay, so I can simply click on this and remove it, as simple as that. If you have any of the, what you say, your metallic ions, this that, you can simply click on them also. Okay, then right click, option will come, remove. Okay, but for water, obviously the red marks that you see over here, you can zoom in, zoom out, everything you can do. Okay, all of the red marks that you see over here are basically water. Okay, so how to remove water? So it is far simpler. Okay, so you just have to go to all. Okay, remove water. Okay, so once you hit on that, everything is removed. Here you can see one more ligand molecule you are having. So how do I know that? People do question me that like the student who are learning it for the first time, so how do I know which one is a protein? You can see it. Okay, so you can like from the visual representation, you can see that protein is made up of amino acid, and it is having your alpha helices, beta sheets, all those structures that you can see over here. Whereas a ligand is a chemical molecule. Here you can see like carbon bonds. Okay, so carbon, oxygen. Okay, so those things, so red ones are oxygen obviously, and this is a carbon bond. Okay, so I can simply see that this is a chemical molecule, ligand molecule. I will just simply remove it. Okay, so here you can see this is the protein by my side. Okay, so whatever like however you want to represent it, you can maneuver it and see. Okay, now I can change it to, I can give it multiple colors also. I can go to mouse and go to selection mode and select a chain. Why? Because so that I don't have to like select one by one residue. Obviously it was in residue previously. Here you can see all of the codes, whatever I have selected till now, everything is coming over here in the form of codes. Okay, so like here you can see, so I have selected the whole protein. Now I can simply again do a right click, go to colors, okay, and do a spectrum rainbow by carbon also I can do. Okay, by different atoms I can do. Okay, so by chain also I can do. Okay, so there are multiple ways. Okay, so I want to do it as a whole. So here you can see, so I did it as a whole. Apart from that, if you want to represent all of the chains by different color, that is also doable. You just select and then go to what do you say, color by chains. Okay, that is there. Here you can see it is a beautiful representation, but we can basically enhance this particular representation. Okay, and for a publication standard or publication worthy image, what you need to do is, first and foremost thing is, the background has to be white. Okay, so or any light color basically. Okay, it can be light gray or basically white. It cannot be black mostly. Okay, for publication. So you have it as white. Okay, so here you can see this is the white. Apart from this, there are a whole lot of things that you can do alongside this, like you can basically change the quality of it. Okay, so you can again go to display. Okay, so color spacing also you can play with. Basically you can do it for your publication standard, so the colors would be a bit rounded off. Okay, so as you can see, the colors are a bit rounded off. Okay, they are not that catchy. Then you can again go to display and go to quality, do it of a maximum quality. Okay, so once you do that, here you can see all of the what do you say, the helices and this would be having a better 3D representation. Okay, so it would be having a fancy kind of a what do you say, representation. Okay, then you can set up grid as well. Okay, apart from that, there are many things that you can play with. You can zoom it. Okay, what do you say, clip only like your 8 angstrom slab. Okay, 12, 16, likewise you can do. Okay, so there are a whole lot of options that you get. Okay, so once you want to do many things, but this are the settings that what I am showing you are absolutely necessary, and basically this particular settings can land you up to your, what do you say, your publication ready, what do you say, your representation. Okay, that is there. So you can maneuver this, and whatever particular representation, or basically whichever phase you like it better, so you can save it likewise. Okay, so prior to that, let's talk about some more settings. So you can go to labels. Okay, you want to like do change in size, font change that you want to do, color change you want to do, that you can do. Okay, apart from that, if you want a different kind of representation like ball and stick, okay, that you can click on. Why I'm not clicking? Because obviously this is the best representation. Why is it so? Because in this particular representation you can see the what do you say, your alpha helices as well as beta sheets. Okay, so that is why this is a better representation. Apart from that, you can also see the side chains which are missing some of the residues, and likewise that you can see. That is why cartoon representation, this is called as a cartoon representation, and this is a very good representation. Okay, and apart from that, if you want to change it, you can do it. Okay, and you can go to cartoon and you can again do fancy helices. Okay, so here you can see, if I do fancy helices, you can see this particular, you would be having a taper end, and like this particular what do you say, broader representation that you are getting for the what do you say, loops out there. Okay, so again you can go to settings. Okay, then you can do multiple like cylindrical helices you can do. If you want to represent the helices in a cylindrical form, that you can do smoother loops, that you can do. Okay, if I want to do it. Okay, so apart from that, you can also again go to your settings and go to ribbons. Okay, and then you can like what do you say, cylinder like cylindrical you can do. Then your surface, if you want to change it to surface like cavity pocket kind of a thing, that you can also do. It takes a bit of time, okay, sometimes to like change it into surface cavity module if you want to change it to. Okay, so transparency, if you want to do it more transparent and all, obviously transparency I have taken it off as of now. Okay, apart from that, this particular things you can play with. Okay, but this is the basic information that you can provide. Okay, apart from that, if you want to like undo anything, you can simply basically click on undo. Okay, so likewise it will work. Apart from that, if you want to like go to settings again and you want to like remove anything, that you can do. Okay, like let's suppose I wanted to remove your smooth loops. Okay, so I don't want to do it of a smooth loops, this looks better to me, so I will keep it as it is. Okay, so likewise, so these are the main settings, and after this you can simply save it. Okay, so you can go to your files. Okay, and then you can save session as also you can do, so that the particular thing is saved as it is, and when you like open it for the next time, it will open from here. Okay, apart from that, you can also go for export molecule if you want to save it as PDF, and here you keep it enabled, and whatever the state it is in, you want to save it in this particular state. Okay, so you keep it as it is. Okay, and then you can go to PDB options. Okay, you can click on this as well if you want to have multiple collections and duplicates you want to include. Apart from that, by the if you want to go by the default setting, you can go by that as well. Okay, so it is already clicked over here, you can hit on save. Okay, and here you can see it is saving in this particular folder for me. If I want to name it, let's suppose protein, I want to name it as protein. Okay, and here you have to change a setting, because this particular thing is already in CIF that we have downloaded in. Okay, but I now wanted to save it as your legacy PDB. Okay, so or like simple PDB or legacy PDB dot gz file. Okay, so I can simply click on this and hit on save. Okay, so I already have by this particular name, so I can hit on replace. Okay, so it will be saved like this. Okay, so we can basically now remove this particular protein that you see over here, and we can come up with your ligand molecule. Okay, so ligand, or basically chemical molecule, how to visualize chemical molecule. So I can simply click on this and remove it. Okay, so I can do undo also, or I can again open PyMol, or so there are many ways, but it is the simplest way. You just remove it and go to display and do it do this particular, what do you say, background as black. Okay, because in the black of course all of the what do you say, colors are more visible. Okay, when it comes to just 3D representation, but for a publication and all, for what do you say, image based thing, background white is better. Okay, so let's go to our Safari and let's talk about PubChem. So okay, so from PubChem we can get the chemical structure. Okay, so PubChem, so we'll take any of the structure. Let's suppose we are talking about aspirin. So this are all of the synonyms of aspirin. So this is a drug, as you all know. Okay, so it acts as a blood thinner. Apart from that, it also helps in your relieving from pain. Okay, to a certain extent. So then you have your, so any kind of representation will do. You want to do it stick or ball and stick, okay, anything will do. So animate, so it will rotate basically. Okay, nothing much. So you can just go to download coordinates and you can download it in SDF format. Okay, so it is possible that you can download it in SDF format. Like JSON is there, XML is there, multiple formats are there, but SDF is more widely used. Okay, so I can just click on SDF format and it would be downloaded over here. Okay, so then I can simply click on this and I'll be redirected over here. Okay, in the PyMol. So let's select this. Okay, so skip activation. I already have one of the tab open, so yeah, in the background. So let's close that and stretch it a bit for for your better understanding. Okay, so yeah, so here you can see this is a benzene ring that you see over here. Okay, and then the C, then your double bond, this are the oxygen molecules basically. Okay, C double bond O. So this is the simple representation of it. Okay, so you can obviously select this one and like you can go to colors if you want to change by colors. Okay, so that you can do. Okay, spectrum is there. Okay, so likewise you can do. So not much is required to do with your ligand molecule. Basically you can do it of a monocolor when we basically do like when we have a docked result, let's suppose. Okay, so I want to change the representation of the protein and the ligand so that what do you say, whoever is seeing that particular representation doesn't get confused that which one is the protein, which one is the ligand. For that particular purpose we can do. Okay, so simple ligand we mostly don't work with, but we can work with, not a big deal. In the selection you can go to labels, you can label it. Okay, so by atoms, everything you can do. Okay, so that is there. So not getting in details of this, instead we will look at the interactions. Okay, so let's remove this for instance. Okay, so let's remove this. Okay, and also like for now just minimize this particular tab and try to, what do you say, your come up with your, or basically you can like go on to our next step. So I already have some of the results so of docking. Okay, so if you want to see how to do docking and all, so I have already repeated a number of times that the video is already there in the channel, so you can go through that. Okay, so I will just show you one of the way. So this particular is also one kind of a representation of how the ligand and your protein is interacting, but this is using a lig plot. Lig plot is another kind of a tool which can also be used for your visualization purposes. This is a 2D representation. Similar representation you will also get in Discovery Studio. Okay, if you want to do a 2D representation, that you can get, but in order to get 3D representation you can go to Chimera or PyMol. Okay, so I will show you using PyMol today. Okay, so this is the complex. Okay, so it is like with a, what do you say, your like immunogenic receptor with your Tinospora cordifolia is a plant, and that particular plant's phytochemical is your cordifoliocyte A. Okay, and cordifolite A, and like multiple what do you say molecules that you have. This particular interaction is with your cordifolite A. Okay, so and this is the screenshot of that, and we can see the 3D representation of the same as well. Okay, so this is the 3D representation. Okay, so yeah, so why I'm not maximizing it, because otherwise the floating window that you see over here will be gone, so that is why. Okay, so this is the representation that you see. Okay, so this is the what do you say, your ligand molecule, and this is your protein molecule. As you can see clearly that it is only having your what do you say, your beta sheets. Alpha helices are not over here. Okay, so that is there. So this is done using Glide. Basically Glide is a paid tool from your what do you say, your Schrodinger. Apart from that, you can also do this particular kind of docking using diffdoc and swissdoc, and likewise. Okay, Autodoc Vina, Autodoc 4, Pyrex. Okay, for your automation likewise. So let's do this particular thing and see that how this particular ligand and protein are interacting with each other. Okay, so now we can't see, because we can't see any of the interactions over here. Okay, so I will select this particular ligand, and I wanted to do it of a different color. Let's suppose I give it a cyan color. Okay, so cyan you can see. Okay, and for a differentiator, okay, I will just go to mouse and go to select chains. Okay, I can do this particular whole protein of a single color, so that to make you understand, I won't do it what do you say, your uh, spectrum or your rainbow representation I want to do. Okay, so instead, let's whatever color you like, you can choose. Okay, let's suppose I'm talking about magenta, we can take. Okay, so yeah, so this are having a good contrast, that is why I'm selecting this. Okay, so these are the two things. So now what to do, how to look at the interaction. Okay, so basically I can select both of them. Okay, so this is the whole protein selected. Prior to that, I have selected the ligand, as you see. Okay, now I can go to action. Okay, so basically, if there are anything that I wanted to do, like remove water and all, I have already done, so not required. I can go to selected. SELE basically means selected. Okay, so in selected, I can go to actions. Okay, in action, I will go to, what do you say, your find. I want to find the interactions. No, so find polar contact, I can do polar contact within selection, that is a possibility. Apart from that, I can also go to any contact and select chain within 3 angstrom. So let me remove this for instance. Okay, so yeah, so here I have all of the options that you see. Okay, so I can go to polar contact, okay, within the selection, that is possible. Apart from that, any contact within 3 angstrom is also a good representation. Okay, so let's talk about polar contact within selection. So it will also give you intermolecular, okay, as well as intramolecular. Here you can see the protein. Okay, like protein is also there, is having its what do you say, interactions in between its own chain. Okay, so that is why intramolecular interactions also you can see, or an intermolecular also you can see. You can see this particular thing. You can see over here that this is going in the 3D space. Okay, but actually you can't see that it is matching, but it is actually matching. Okay, so like it is interacting with protein only. Okay, but it is in the 3D space, that is why you see that it is somewhere like there are missing areas or gaps. It is not there. Okay, so it is in a 3D space, that is why it seems like that. Okay, you can also do it like you can deselect it also, so you can do a undo likewise. Okay, so it will go to all of the representation that you have used, how many times you have moved it, that you can do. So apart from that, if you want to like go back to your, what you say, what you have selected, let's suppose likewise you can do. Or apart from that, you can also do one thing, that you select both of them. Okay, and then go to your like in the selected part, you can go to your find any contact within 3 angstrom. Okay, so when you click on this within 3 angstrom, you can see all of the interactions within 3 angstroms are being shown over here. Okay, here you can see the bond length is shown over here, but there is a problem. What is the particular problem? The particular problem is that you can't see the particular atom name, and that is obviously a problem. So we need to select the atom name. So what is to be done for this particular atom atomic representation? Because we want to know which particular residue and which particular atom from the ligand is interacting with which particular what do you say, residue of the protein. Okay, that is very important. Without that, how would I know that what it is interacting with? Okay, so for that, you can again go to selecting all of them. Okay, so protein and ligand, and now you have to go to labels. Okay, and in labels you can do two things. Okay, so you can name the, what do you say, residues. Okay, so one letter code also you can do. Okay, one letter code you can do, or the whole residue name you can do. One letter code is easier to understand, so let's do one letter code. Okay, so once you do that, all of the one letter codes are being mentioned over here. Okay, after this you can again do atom based on atoms also. Okay, so atom name. Okay, so atom, by atom name or elements you can do atom name. Let's do. Okay, so here you can see all the representation. Okay, Hg22, He21. Okay, so likewise you have the residue as well as the atom name, but This is too much of information to process, isn't it? So this much of information is hard to process for you. So, and you can't see the bonds as well. Okay, so what is the way how people do it? So it is very simple. Just you have to select the ligand this time around. Okay, not the protein. Okay, so once you select the ligand, go to your all action. Okay, so all selected all. So then your action, and then you can go to your origin, or basically orient, or you can also go to selected. Okay, selected, and you can go to orient. Okay, so that only the selected part would be oriented. What is the orient option? This particular orient option basically blurs all the else things out so that you can focus on the interaction. Now you can see the interaction. No, so here you can see the interactions over here, so that the like a 10th hydrogen is interacting with your like Hg3 with a 2.7 angstrom bond. Okay, apart from that, if you want to like give it a, what do you say, like this particular protein part. Okay, so this particular protein part, if you want to give it a another label, like your what do you say, element symbol or residue name you want to give it, so that is also doable. You can see leucine, glycine. Okay, so what is this? So that is also another way. Okay, apart from that, you can also, alongside this particular representation, you can give it atom name. Okay, so likewise, either you give it a you can see the atom name. Apart from that, your residue is also possible. Whatever works for you, that you can give. Mostly we use atom to atom. Okay, so now again the same thing. Select this particular what do you say, ligand. Go to the selected. Okay, then your orient. Okay, in the orient, what happens, it is just like portrait, so all of the background things are blurred out, so that you can focus on the main things that are there. Okay, so you can zoom it out, and then you can maneuver this particular whole structure, okay, in n number of possible ways, so that you can count upon them. So here you can see the 10th H is interacting with Hg, okay, with a 2.7 angstrom bond. Okay, so obviously all of the things that we have selected are below 3 angstrom, and those are good bonds. Basically anything which is below 3 angstrom is considered a good bond in chemistry. Apart from that, the lower the bond length, okay, or the shorter the bond length, better strength the bond is having. So the interaction between the ligand and the protein is a strong one. Okay, so that we can conclude from here. Likewise, you can select and you can make a table out of it, that what are the interacting bonds, okay, in the 3D space. Apart from that, whatever representation you are getting in the 2D, using your Discovery Studio, likewise you can cross validate those particular results using your PyMol in 3D. Okay, in PyMol or your Chimera or Rasmol. Okay, likewise any of the visualization tools, you can basically cross validate the results. Okay, so there are many ways how you can cross validate the results of your docking. Basically after docking, you can look at that particular tool. Let's suppose you are doing it using SwissDoc. You can click on that and see the interactions over there, what are the bonds it is supported using. Apart from that, you can also do the interaction, learn the interaction from your 2D 2D representation from your Discovery Studio and all. Apart from that, you can also come to the 3D representation for cross validation using your PyMol, Rasmol, Chimera, and this that. Okay, that is there. So that is there. You can also save it. You can take a screenshot of it, or you can save it in a number of ways. I have already shown you how to save it. Okay, so if you want to save in this particular form only, you can again go to the same thing, like save session as and export molecule. Okay, then save it in the form of pdb, including, click on all of them, including all the interactions and in this particular state. Okay, and likewise you can hit on save, or you can take a screenshot, whatever works fine for you. Okay, so that is there. So that is all from my side as of today. Okay, so this is about the representation. So see you in the next ones. We will come up with more of such videos. Okay, and if you find some value out of this particular demonstration, please hit the like button. Okay, and share with your keens and peer ones, and also do please subscribe to the channel. Okay, so that we can get motivated and we can come up with more of such demonstration for you for free. Okay, so that is all from my side. This is your host Pradip Banerjee signing off from this particular channel, and see you in the next demonstration video. Bye bye, take care, have a good health.